Hello friends, this is my first video tutorial in which I am going to explain number systems and their interconversions. So number systems are a very important part in digital electronics. So again, what do you mean by digital electronics? So there are two basic ways of representing the numerical values of the various physical quantities. One of the ways referred to as analog is it is to express the numerical value of the quantity as a continuous range of values between two expected extreme values. Whereas the term digital represents the numerical value of the physical quantity in steps or discrete values. Here, the two graphs are distinguishing between analog signal and digital signal. So, analog signal is continuously time varying, whereas a digital signal is discrete with respect to time. Here there are two examples. Again, visualize difference between digital and analog. So one instrument is a multimeter and another is clock, so which distinguish the difference between presentation of digital and analog. So when we are talking about digital, it is very important to talk about bit and byte. So what do you mean by bit or bytes? So bit means a single digit in a binary number system. It may be either 0 or 1. So in next slide we will learn what is binary. So remember here bits means a single digit in a binary. So it may be either 0 or 1. Byte means it is a group of 8 such a bits of 0 or 1. So group of 8 bit is nothing but a byte, and then its bigger units are kilobyte, megabyte, gigabyte and so on. So 1 kilobyte means 1024 bytes. Now how this 1024 comes? So 1024 is nothing but 2 raised to 10. Again, why 2 raised to 10? Because 2 is a base of binary number system and therefore 2 raised to 10 is equal to 1024 kilobytes, and subsequently 1 megabyte means 1024 kilobyte, 1 gigabyte means 1024 megabyte and so on. So this memory, suppose a 1 kilobyte or 2 kilobyte memory means a typewritten page. A 1 megabyte memory means a small novel written. 1 gigabyte means a pickup truck filled with books, or the capacity of storage of DVD is 4.7 GB. Bigger units, terabyte, petabyte, exabytes, are larger bytes as compared to this megabyte, gigabyte. So our focus is to learn the number systems. So in day-to-day activity, whatever number system we use, that number system is decimal number system. But in digital electronics, that number system is not useful, and instead of that, the number system is useful is binary number system. And there are some other number systems called as octal number systems and hexadecimal number system. So decimal number system, it contains 0 to 9 digits. So 0 to 9 means it has 10 digits, so its base or radix is 10. So decimal number system, which is useful in day-to-day activities, has 10 digits which contains 0 to 9 digits. Binary number systems, which is useful in digital electronics, which contains only two digits, that is 0 and 1. So It contains only 2 digits, therefore its base or radix is 2. The third number system is octal number system, which contains 0 to 7 digits. Octa means 8, so 0 to 7 digits means total 8 digits, so its base or radix is 8. And the fourth number system is hexadecimal number system. So hexadecimal number system consists of some alphabets and digits. So hexadecimal number system consists of 0 to 9 digits and A to F alphabets. Therefore, its base or radix is 16. So these are the 4 number systems: decimal number system, octal number system, binary number system, octal number system, and hexadecimal number system. So now we learn the basics of the number system. The base of decimal number system is 10, base of binary number system is 2, base of octal number system is 8, and the base of hexadecimal number system is 16. So how to convert a given number into another number system? For example, how to convert a decimal number system into other number system? So if you have given a decimal number and we want to convert it into another number system, for example binary, then progressively divide by r and the remainders noted until the result of division is a zero quotient. So progressively divide the given decimal number divide by 2, and whatever your remainder, note down that remainder in a reverse order. This method is also called as double method. So similarly, from decimal number system to binary number, octal number, or hexadecimal number, we can convert the number by dividing 2, by dividing 8, or by dividing 16 respectively to convert into binary, octal, or hexadecimal. So here one example is given. Convert 34 decimal number into binary, octal, and hexadecimal. So take that number 34, and if we want to convert it into binary, means the base of binary or radix of binary is 2. So 34 divided by 2, quotient is 17, remainder is 0. Take this new quotient as a next number, 17 divided by 2. So quotient is 8, remainder is 1. Continue this process of dividing the next quotient up to the quotient will come to 0. And whatever your remainders, write down that remainders in reverse order so that the equivalent of 34 is equal to 100010. So this is conversion of decimal 34 into binary. Similarly, if we want to convert a given decimal number into octal or hexadecimal, at that time divide this number by 8 or 16, and again whatever your remainder, write down that remainder in reverse order. So here the example is given for decimal to octal. So 34 in decimal is equivalent 42 in octal, and 34 in decimal equivalent to 22 in hexadecimal number system. So this is one conversion. In another part, a reverse procedure, vice versa, means if a number is given in another number systems like binary, octal, and hexadecimal, how to convert these numbers into decimal? So again the reverse procedure. The sum of all the digits multiplied by their respective places values. For example, for binary, multiply each binary bit by 2's power. For octal, multiply each binary by 8's power depending upon its place values, and for hexadecimal multiply by 16's power according to its place value and make its summation, that will give you a decimal number. So here one example, how to convert a binary octal and hex into decimal. So number is given to you 101111. This is a binary number and it is a 6-digit number. So for conversion binary to decimal, we have to multiply it by 2's power. So start from right side. So 1 into 2 raised to 0 plus 1 into 2 raised to 1 plus 1 into 2 raised to 2 plus 1 into 2 raised to 3 plus 0 into 2 raised to 4 plus 1 into 2 raised to 5. And according to that, after multiplication, whatever we got, make the sum of that multiplication. So the number is 47. So in other words, we can say that the bit multiplied by power of radix. For example, 1 into 2 raised to 0 means we can say that 1 into r raised to 0, 1 into r raised to 1, 1 into r raised to 2, 1 into r raised to 3 plus 0 into r raised to 4, 1 into r raised to 5. Here r means radix or base of that number system, and here the number system is binary. Therefore we multiply the binary bits by power of 2 and addition of that will give us a decimal equivalent of given binary. The same procedure will be adopted for conversion of octal to decimal and hex to decimal. So one problem will be there in hexadecimal number system. If the number is greater than 9, if the number is greater than 9 at that time, there will be alphabets A, B, C, D, E or F. For example, here the number is given 2F and you have said that convert this 2F into decimal. So according to definition or according to formula, decimal number is equal to the bit 0 multiplied by r raised to 0 plus bit 1 into r raised to 1. So here f into 16 raised to 0 plus 2 into 16 raised to 1. So again, what do you mean by f? So f means again 15 in decimal. So 9 up to 9 decimal and hex are same, but after that in decimal there is a 10, whereas in hexadecimal there will be a. Similarly for 11 in hex B, 12 in hex C, for 13 D, for 14 E and for 15 F in hexadecimal. So write its equivalent decimal for multiplication so that it will become 15 into 16 raised to 0 plus 2 into 16 raised to 1. So 32 plus 15, 47. So equivalent of 2F hex is 47 in decimal. So here we learn how to convert the decimal numbers into another number systems like binary, octal, hexadecimal, and also we learn vice versa, means if a number is given into other number system such as octal, binary, octal or decimal, and how to convert these number into decimal number. So thank you friends for this attending this short video. Thank you.